question is, a doped semiconductor specimen has the Hall coefficient 3.6 into 10 power minus 4 meter cube per coulomb, the resistivity 9 into 10 power minus 3 ohm meter, assuming single carrier conduction, the mobility and the density of carriers in the specimen are approximately. We know that sigma is nothing but mu into RH, so mobility is nothing but, here conductivity is also inversely proportional to the resistivity. So mu is nothing but rho into RH, which is nothing but, from the given values, it is going to be 0.04 meter square per second. Similarly, single carrier density of carriers, that is NQ, is nothing but 1 by RH, that is Hall coefficient. From this, N equals to 1 by RH into Q, that is nothing but 1.74 into 10 power 22 per meter cube. Hence, option A is correct. Here the question is, an edge-triggered synchronous binary counter is provided with a clock, control inputs, active low clear, that is CLR bar, active high load L, and active high count C. The correct matching between column A and column B is, here clock is active. First one, CLR bar LC is 1x. So 1 is, because it is count, first one is Q R S P is the correct combination here. Okay, this is the correct combination for this. Question is, for the truth table given in the figure, the minimized Boolean expression is, here the expression for P is nothing but, here this x bar y exclusive z whole bar plus x y exclusive z, means x exclusive y exclusive z whole bar. Hence option B is correct. Next, for the circuit shown in the figure, the p-channel JFET transistor parameters are IDSS is 6 milliamps, VP is 4 volts. The source to drain voltage and the region of operation of the transistors are, here 0 minus ID minus VSD minus ID into 0.4K plus 5 equals to 0. Okay, now here 0 minus VGD, here from this 0 minus IDRS minus VSG equals to 0, means VSG is nothing but minus IDRS. Here VGS is nothing but IDRS. Here RS is 1 kilo ohm ID. So ID is nothing but IDSS 1 minus VGS by VP whole square. Okay, now if we substitute this one, we will get ID from this one. Okay, after getting ID from this one, from the equation 1 we will get VSD, that is VSD we will get as 2.47 volts, and this equation is valid for the saturation region. There is no active region in the p-channel JFET, hence option D is correct. Here the question is, figure showing an interfacing circuit from an 8085 microprocessor to read an 8-bit data from an external device. The appropriate instruction for reading the data is, here in order to enable 3 by 8 decoder, say A3, A3 to A7, A8 to A15 must be all or ones. Okay, means A15, A14, A13, A12, A11, A10, A9, A8, A7, A6, A5, A4, this all are must be 1. So this combination gives F, this combination gives F, this combination gives F. But A3 also must be, and A2, A1, A0. So A3, A2, A1, A0 must be 2 because we have to select Y2 line. So it must be 0, 1, 0. This is 1. So this is going to be A. So address we have to use is FA. FFA. But sir, here we are using an interfacing circuit. Means it is kind of an IO mapped IO way. IO address is going to be lower order byte of the complete 16-bit address of the 8085 microprocessor. Hence, this lower order address is enough to enable the data, that is INFAH is the suitable instruction. Hence, option B is correct.
We have to find the value of the integral over the curve x square plus y square is equals to 4. Now let us take this expression as m, that is xy square plus 2x, and the next expression as n, that is x square y plus 4x. Now dou m by dou y is nothing but 2xy. Dou n by dou x is nothing but 2xy plus 4. Now dou n by dou x minus dou m by dou y is nothing but 4. Now let us use the Green's theorem to solve this problem. So what does this Green's theorem say? Integral over c m dx plus n dy can be written as double integral over the region dou n by dou x minus dou m by dou y into dx dy. This is nothing but, if I take y as 0, the values of x will be minus 2 to plus 2, and the value of y will be nothing but minus of root over 4 minus x square to root over 4 minus x square into dou n by dou x minus dou m by dou y is nothing but 4 dx dy. And also clearly the function is even, so I can write this first integral as 2 into integral 0 to 2, and the second as y is equals to 0 to root over 4 minus x square into 4 dx, that is into 2, one more 2 here, which will be nothing but 16 into 0 to 2 and 0 to root over 4 minus x square dx. So which is dx into dy everywhere can be written as 16 into 0 to 2 dy y from 0 to root over 4 minus x square dx. This can be written as 16 into 0 to 2 root over 4 minus x square dx, which is equals to 16 into 0 to 2 root over, I can write this as 2 square minus x square, which is in the form of root over a square minus x square dx integral. Let us substitute the values in the formula. 16 into, what is the formula of root over a square by root over a square minus x square, which is nothing but x by 2. X is nothing but 2 here. So let us write the formula first. X by 2 into root over a square minus x square, that is 4 minus x square. X is nothing but 2 here. No, let us substitute x afterwards. Plus a square by 2 sine inverse x by a. Now a is nothing but 2 here, so this will become 2 square. So if I substitute the limits from 0 to 2, you will get the value as 16 into 2 into pi by 2, which is 16 pi. As if I substitute x as 2, this term will become 0, and this is 4 by 2, that is 2, and sine 2 by 2 is 1, that is pi by 2. Now similarly, if I substitute x as 0, this term will become 0 with respect to this, and sine inverse 0 is 0. So entirely the answer is 16